All right, guys, so we're going to derive the derivative of a standard logarithm. So we need to recall a couple things. First of all, recall that the derivative of natural log of x is 1 over x. Okay, so that's the first thing we got to recall. The second thing we got to recall is a log property, right? So if I gave you log a of b, let's just use two constants instead of an x, right? This is equal to the natural log of b over the natural log of a, right? So that's our change of base formula. Remember our change of base formula, and remember our natural log of x, the derivative of natural log of x. Now, if we remember those two things, then we can find the derivative of log a of x. So, how we're going to do this is we're going to rewrite this as the derivative of, and I'm going to do the change of base formula, which will be the natural log of x over the natural log of a. Okay, so this guy goes on top, this guy goes on bottom. Okay, natural log of x over natural log of a. Now, I can use the quotient rule. Remember, the quotient rule says if you're taking the derivative of a fractional thing, then you can find the derivative by saying what? It's going to be n prime d minus n d prime over d squared, right? So that's the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator times the denominator divided by the denominator squared. So this is equal to, and let's see what we get. So the derivative of the numerator is 1 over x times the denominator, which is the natural log of a, minus the numerator, natural log of x, times the derivative of the denominator. Well, the derivative of the denominator, the derivative of natural log of a. Natural log of a would be like the natural log of 5, the natural log of 8. Those are constants. The derivative of a constant is 0. Therefore, this entire piece goes away. And then our last step is to square the denominator. So we take the natural log of a squared. Okay, natural log of a squared. Cool. Now what? Well, we have a couple of options. My simple way of looking at this is I have natural log of a in the numerator, I have natural log of a in the denominator, so what's going to happen? One of those will cancel with one of those. What am I left with? I'm left with 1 over x divided by the natural log of a, right? So that divided by that, okay, which is 1 over x times 1 over natural log of a, right? Keep, change, flip. So what do we get? The derivative of any logarithm, log a of x, is equal to 1 over x ln a. Okay, x ln a. So we have a rule. We have a rule for our logarithms. So if we were to take, let's say, a problem where we had the derivative of log 5x, right? So plug in our numbers here, right? What do we get? Our derivative will be 1 over x times natural log of 5. That's it. It's that easy. Cool. What if we had the derivative of log 3 2x plus 1? Okay, what if we had that? Log 3 2x plus 1. What would happen here? Okay, well, we have to view this as what? The derivative of log 3u. The good old chain rule, right? Well, what is the derivative of log 3 of u? You're going to follow this rule. So this derivative is going to be, right, log a of x is 1 over x ln a. So log 3 of u would be 1 over u times ln 3. And then because you used the chain rule, you have to multiply by what? U prime. Cool. Well, u ln 3, there's u times ln 3. Pretty simple. U prime. Well, the derivative of this statement, of this argument, is just 2. So I get 1 over 2x plus 1 ln 3 times 2, which gives me what? 2 over 2x plus 1 ln 3. Okay, so there's our derivative for that. So those derivatives would be for standard logarithms, not natural logarithms. So, and then, of course, we want to go into a few other issues, a few other questions, a few other problems. So let's try a couple of fun examples. So we've gotten this guy, we've gotten that guy. So we know our two derivative rules now. So let's try a few examples, okay? So the examples here, we'll just say find the derivative. We'll say find the derivative, okay? And here at the top of the paper, we're just going to write our rules. The derivative of log AX equals, make sure we write it down correctly, derivative log AX is 1 over x ln A, and the derivative of a to the x, right? The derivative of a to the x is a to the x ln A, okay? So we make sure we've got these two rules handy. These two rules really, really handy for this particular assignment. So with those two rules handy, let's try a couple, okay? So y equals 7 x to the 4th plus 2x, okay? So of course this is in this form. So, and of course we want to find y prime. So there's our answer, y prime. So what do we need to see this as? We need to see this as y equals 7 to the u. Okay, 7 to the u. So therefore y prime would be equal to what? Follow our rule, right? A to the x is a to the x ln A. So this would be 7 to the u times the natural log of, and right, our base A is 7 times u prime. Okay, so that's going to be 7 x to the 4th plus 2x times the natural log of 7 times u prime. What is u prime? U prime's the derivative of this guy that you substituted with a u, which is going to be 4x cubed plus 2. So that's going to be 4x cubed plus 2. And then however you want to write this, that's going to be your answer, okay? So you very easily could just leave it in this format. Most folks will put this guy first, this guy last, and this guy in the middle, okay? So we'll say 4x cubed plus 2 times 7 x to the 4th plus 2x times the natural log of 7. Okay, that would be our typical way that we would write this answer. Okay, so there's number 1. Okay, where's the number that? Number 1. Number 2. Okay, let's try a different one. What if we had a similar problem? Y equals log 9 of x to the 3rd plus 3x squared plus x. Okay, so we got this wonderful logarithm problem. What have we got? We've got log A of x. Well, because this isn't an x, we have to use the chain rule, right? So we have to look at this and immediately see y equals log 9 of u. Log 9 of u. And basically, you're going to take this and put a u in your definition. So y prime would be what? It would be 1 over u times ln of 9. But because I used u substitution, I have to also multiply by what? U prime. Okay, so u ln 9 times u prime. Well, then we just fill in. Okay, so this is going to be 1 over u times ln 9 times u prime. Well, what is u prime? U prime is the derivative of this guy, which is going to be 3x squared plus 6x plus 1. So what is y prime? Y prime is equal to this fraction here, 3x squared plus 6x plus 1 over x cubed plus 3x squared plus x times the natural log of 9. Okay, so that would be y prime. Okay. Number 3. What if we get something like this guy? Okay, so let's get y equals 6 to the 2x plus 1 over log 3 of x. Okay, this is a big one. This is a lot going on here. So what do we have? We have a fraction. So the first thing you got to see before you see anything else is that y prime is going to equal n prime d minus n d prime over d squared. Okay, and this is going to be what? The numerator's derivative times the denominator minus the numerator times the denominator's derivative over the denominator squared. Now, a couple of things. This derivative here is going to use the chain rule. This derivative here will not. Yay! But so we got to figure out n prime, right? So I like to come off. I call it side work. I'm going to come over to the side and find n prime. So what is the derivative of 6 to the 2x plus 1? Well, we have to see that as what? The derivative of 6 to the u. Okay? Well, the derivative of 6 to the u is going to be 6 to the u times natural log of 6 times u prime. Okay? So what do we have? Well, 6 to the u is 6 to the 2x plus 1 times the natural log of 6 times u prime is that derivative, which is just 2. Okay? So that is n prime. All of that is n prime. So when I come down here and write y prime equals, and I have this big long fraction bar, I'm not crazy because that's n prime. So n prime, and I'm going to write it in a different order. I'll put that 2 out front. So it'll be 2 times 6 to the 2x plus 1 times the natural log of 6 times the denominator, which is log 3 of x. Log 3 of x minus the numerator times the derivative of the denominator. Well, the derivative of this guy does not require the chain rule. Log 3 of x is going to be what? 1 over x ln 3. Cool. And that's all going to be over what? The denominator squared, which in our case will be log 3 of x quantity squared. Okay? And of course, this guy and this guy are common. but there's no common term here, so there's really no way to try and simplify that. The one thing you can do, the one thing that you can clean up here, is that you can, right, you've got this guy in both of these, and so you can clean that up a little bit. And so really from here, we do have, that's y prime. I don't know why I didn't put the prime symbol. But we do have the derivative, and it's really just from here down is cleaning that up, okay? So how do we clean that up a little bit? Well, I can pull this guy and this guy out, and so I'm going to get something like this. I'm going to get y prime equals 6 to the 2x plus 1 times, let's see, so 2 ln 6 times log 3 of x minus 1 over x ln 3, and that'll all be over log 3 of x squared. Now, the only other thing you could do here, and I think it would honestly almost be torture to do it, but the only other thing you could do here would be to take this guy and try to combine them, because of course this is a fraction, so the common denominator would be x ln 3, and then so you could combine these. But I think from there we're going to leave it. We're not going to go any further. Hopefully your instructor doesn't make you go any further, because at this point this is quite usable, and that's really as far as we need to go. Your other option, of course, would be to break this into, before you factored this out, you could break this into two fractions, which would simplify this guy, and then you could simplify this compound fraction part here. It really just depends on who you ask, but I think this is about as simple as I want to make it. Okay, so that's our derivative. Fun. So let's try perhaps one more. Okay, so whoa, we pulled up our calendar by accident. Let's take that off there. Okay, so let's try one more. If I ask you to find the derivative, right, of, and let me find the problem we were going to do here. So I've got log 9 of 2x times 4 to the x to the 6th. Okay, so one more problem here. Okay, so this is a fun problem, right? Fun for me at least, maybe not for everybody. Okay, so we want to find this derivative. So what do we have to recognize as soon as we see this? That we have what? Two unique functions. So this is A and this is B. And so we have to use the product rule, right? So the product rule says A prime B plus A B prime, right? So basically we're going to break this down into 4 chunks. So let's start with A prime. Okay, so A prime, we know log A of x is 1 over x ln A, so this is going to be 1, my goodness, breaking my lid here, 1 over u times ln 9 times u prime. Okay, so that's A prime. And that's going to be 1 over 2x ln 9, and u prime is the derivative of 2x, which is just 2. So if I say times 2, that'll make that guy a 2. And then, of course, right, 2 over 2, what do we get? We get 2. No, we don't. We just canceled that out. We don't get a 2. Getting ahead of myself. What do we get? We get 1 over x ln 9. Okay, 1 over x ln 9. Cool. Then what? Times b. Okay, so b, I'm not going to do any work. I'm just going to come down here and say times b, and b is going to be 4 to the x to the 6th. And of course, we know we can put that together. Now, plus a b prime. Well, a, we're just going to come all the way down here. A is log 9 2x times b prime. So b prime, again, we have to look at this like what? We have to look at this like u to the 6th. What is the derivative of u to the 6th? It would be 6u to the 5th times u prime. Okay, so that would be 6u to the 5th times u prime. Well, u prime would be the derivative of 4 to the x. Well, the derivative of 4 to the x is a really simple rule. That's going to be what? 4 to the x times the natural log of 4. Fair enough? So that is u prime. U prime is that. 4 to the x, right? A to the x times natural log of a. Okay? Now, here's the tricky part. You've got 4x, 4 to the x to the 5th times 4 to the x to the 1st. Okay? U to the 5th times u to the 1st. Right? Again, let me write that somewhere so you can see it. U to the 5th times u to the 1st. Right? U to the 5th times u to the 1st. What do we do when we multiply two things that have exponents? We add the exponents. Okay? So what we end up with here is actually 6, 4 to the x to the 6th, right? So the 5 plus the 1, 6, times the natural log of 4. So basically we end up with our original expression times 6 times natural log of 4. Okay. And then of course there's the plus sign between these. Don't forget the plus sign between these. Now what? Let's combine some like terms, get some things together. So what do we have here? We have 4 to the x to the 6th over x ln 9 plus all of this, right? So we have, I'm going to go ahead and put this out front. So I'm going to have 6, 4 to the x to the 6th times the natural log of 4 times log 9 of 2x. And that doesn't have any denominator at all. So then what? Well, we could combine these two, right, by multiplying by that. We could factor out this common factor, which I'm going to do. That's about it. Okay, so we have to simplify this somehow, some way, right? And by the way, since it says d dx of an expression, you don't want an equal sign in your final answer. So you don't want y prime equals because they never defined y. So keep up with that. Okay, so anyway, let's factor out that common term. So we get 4 to the x to the 6th times what? Right? 6 times ln 4 times log 9 of 2x. So I'm going to put this guy first, plus 1 over x ln 9. Okay, that would be our final answer for our derivative. Okay, and if you follow me through that, I can't make them any more complicated, and so you're spot on with this. If you have questions, leave them in the comments. I hope that helps you, and if you need to, shoot me an email.